Django Boston. Thrilled to be back both at Django Boston, which I'm very glad is running again, and at the CIC. My company actually got its start. Some of our early years working out at the co-working space right over there, so great to be back here. I'm going to talk about today CHAMP, a website we built with the Massachusetts Office of Housing, which is the online application for state-aided subsidized housing for all of Massachusetts. But first, and before I tell you what all those words mean, if you don't already know, who am I? I am Zags. That's a last name-based nickname if you haven't seen those before. It's not short for Benjamin. And I am the co-founder and chief technology officer at Zagorsky, so I'm sure if you forget. We are a Boston-based software consulting firm. We do full stack, web, mobile, backend, server management, the whole gambit. Django is our primary, but not our only backend. And we do public and private sector projects. I love this as a mix of projects because private sector really pushes you on the technology fronts, really pushes you to be on the cutting edge. And public sector pushes you on the requirements complexity. A phrase that I actually want to push back against, something I really disagree with, is the phrase good enough for government work. Meaning you can just do a slapdash job, check the boxes, and call it a day if you're working with the government. That has not been my experience at all working with the state government. At least in government software is extremely demanding in terms of requirements complexity and also just some of the use cases that these systems get put through. So on CHAMP, we have over 10,000 monthly users. Most of those are applicants. They're in the system all times of day. So we have a constant uptime requirement. And the non-applicants, the people reviewing applications and the people reviewing how the system is used, there are hundreds of them. And these people are working in CHAMP as their primary job. So during business hours, we have hundreds of users hitting that system constantly, as well as our 10,000 monthly users in the system around the clock. We have a lot of data. It's not the biggest, we're not talking Instagram here, but we still have terabytes of files. We have almost 24 tables with over 1 million rows. And we have over 4 chapters of regulation that we had to capture in the functioning of this piece of software. So there's a lot of interesting things we've done in the course of building this, a lot of challenges we run into, and I'm going to tell you about some of those, and hopefully you can take some of my learnings to your own software. So first, we'll do a quick overview of affordable housing in Massachusetts, talk about what we built, how we did it, and then some of the most interesting challenges we ran into in the course of this project. So first, affordable housing. It is a big umbrella. Big thanks to the Office of Housing. I've been working with them for almost a decade. It's really been a pleasure, and also thanks to them for letting me give this talk. They manage a ton of different programs. We're going to focus in on actually 2 categories of programs. There's several programs under this umbrella. But public housing, that's cases where they've funded development of housing developments, where those units are then leased for below market rent to low-income families. And then vouchers are where they give a voucher to a low-income family who goes and rents their own home or apartment, and the Office of Housing pays for a portion of the rent to make that affordable. Both of these are long-term rental assistance to try and help these low-income families actually be able to have a stable home, build a career, build a life. And a big segment of the population addressed by these programs are emergency homeless applicants, people that are suddenly homeless or about to become homeless, to try and get these people back on their feet. A big challenge of housing is that there's not enough of it. You may have heard of the housing crisis, people use similar terms. And what this means is that for housing as a government benefit, it's actually more complex to administer. We can't just take a case management model where applicants apply, get reviewed by a case manager in parallel, approved or rejected. Instead, people are applying onto a waiting list, and then once a unit or voucher is available, some amount of time in the future, could be months, could be years, that's when those people are getting pulled into screening, and they're pulling the top of the list. This is ranked by priorities. Certain types of homelessness get to the top of the list, and otherwise by timestamp. We've got that first come, first served model. And that temporal distribution creates a lot of complexity. It means that we need to have applicants in the system for a long period, keeping their information current, and we also need to get applicants back in the system and involved into a workflow in the future when they're not necessarily thinking about an application they put into the system in the past. There's also a data complexity to this because housing is a local benefit. If somebody wants housing in one of several different towns, they have to apply to several different housing authorities. And so there's a lot of data complexity that comes out of applicants applying to, in many cases, dozens of different housing authorities because they're willing to live in a geographically distributed area. Massachusetts, we're an old state, we don't believe in counties, everything's by town. So we have over 200, there's almost 250 housing authorities in the state, and we have to manage the interplay of applications with all of these. Before CHAMP, this system was very bad from an applicant's perspective. Applicants had to do everything on paper. And by on paper, I mean they had to take an application, make a separate copy, and mail it or bring it in person to every housing authority they wanted to apply to. In many cases, dozens. If their information changed, if they changed address or had a new kid, they had to send a paper update to every single housing authority. And then later, that screening process, every housing authority was sending out mass mailings to all of the applicants at the top of their list. Applicants were responding by mail, potentially having a few more back and forths before they could get verified and housed. Not great. Also, the Office of Housing had no visibility to the system. If they wanted to know something basic like how many homeless people got housed last year, they had to send out a survey to every single housing authority. So in 2014, the state legislature said, implement, I love this phrasing, this is literally from the legislation, a centralized internet website. I do not know what a non-internet website is, but this is what they said. But centralized is really important, and website is really important. So this was the mandate we were working off of when we built CHAMP. So CHAMP, the Common Housing Application for Massachusetts Programs, we absolutely finagled that to make a cool acronym. Digitized and centralized. So digitized, applicants can now apply online, update their information online, and almost all of them do. Not all of them. You can still apply on paper. This is for access reasons, but to apply on paper, even this is easier because of the centralization. You can send in one application to any housing authority, and they will enter it into the system, and that will be in the system for everybody. And same deal for screening. Screening you can now do all digitally. You can opt out of paper mail as an applicant. You can get your notices digitally, upload your documents digitally, just take a picture with your phone. And those documents then get made available to every housing authority that you've applied to. So any proof of ID, your income statements, all of that stuff. You don't need to send it to every single housing authority that's screening you. So digitized and centralized, we've made this way easier for applicants. Broadly speaking, here's what we built. There's more features than this, but these are the broad strokes. We got a dynamic application. So here we've got the questions you answer, change based on what you answered to previous questions, which programs you're applying to. We'll talk a little bit about how we do this in a sec. Automatic waitlist ranking. What you answer, that then feeds into an automatic ranking of the waitlists. So when a housing authority has a vacancy or an available voucher, they just fill in the parameters of that. We give them the top cut of that waitlist automatically. We then generate screening letters. I'll tell you basically how we build every piece of this, at least technologically. We generate screening letters. These are PDFs that can either get printed for sending by mail or email to applicants for people receiving digital. Some people get both. Applicants then give us those screening documents back. We have digital document storage for that with document tagging and organization. Housing authorities then record determinations. That then feeds back into the waitlist ranking. How an applicant ranks on the waiting list is a combination of both what they claimed and how they got reviewed. And then finally, the top eligible applicants get housed, and we track them through this whole process for reporting, get that data visibility. The impact of this has been huge. CHAMP has been live for a number of years. Thousands of people are housed each year through CHAMP, including over 1,000 emergency homeless applicants a year. And while, yes, these programs existed before, I do not believe that this number was anywhere near as high. First of all, they didn't even know this number before. So now not only do they even know these numbers, but these programs are now massively more accessible to homeless applicants. Would you believe homeless people very bad at receiving mail at a physical address? So, all digital experience, much better for homeless applicants, that most vulnerable segment of the low-income population we're trying to serve. Easier for applicants in general. Even non-homeless applicants have a much easier time applying to public housing, participating in the screening process. It's less work for the housing authorities, at least per applicant. Applicants are doing a lot of the work themselves of entering their own information into the system, uploading their own documents. And a big piece of the screening process, screening of those priorities, has now been centralized. It's now handled by a central agency. Housing authorities don't have to do it anymore, which is only possible because of CHAMP. And finally, the Office of Housing now has massive data visibility. They've got tons of reports. They've got a data warehouse where they can do self-service reporting. And they can now answer questions like how many emergency homeless applicants got housed last year, which they just couldn't before. So how do we do it? I bet everyone in this room can guess the first technology that's going to be on my list on this next slide. Django. It's Django! All right, so obviously we built this in Django because of where I'm giving this talk. We didn't do that alone. So broad strokes, we also use Vue. I'll tell you more about this in a sec, but we are using Vue not for our full front end, but just to augment the front end. Django's actually powering a lot of our front end, because Django's got a lot of those great front end features. For hosting, we're using Elastic Beanstalk. That's Amazon's platform as a service. We're also using that for our task framework. Elastic Beanstalk Workers lets you take asynchronous tasks and scheduled tasks and actually turn them into web requests so you can implement your task framework in Django. I have more stuff than is going to fit into 25 minutes, so I'm going to cheat. So here's the first of my cheating. If you want to know more about hosting and DevOps, I gave a talk about this at DjangoCon last year, and here's a link to that. I'll also have these codes up at the end, so I'm going to go by these a little fast. Come ask me if you miss one. So Django itself, I could probably give a whole talk, but here's my top 6 things that Django has done for us on Champ. First, rapid prototyping. To get our start on this project, we built a prototype leveraging Django's ORM and templating in 2 weeks to build stakeholder confidence. And that was really critical in us building momentum on this project and proving that this would actually work as a technological solution. And also, even on a mature product, Django enables us to iterate quickly on features, new features that we're building. Great part of Django. Django's strong security model, automatic injection protection, automatic CSRF protection, the list goes on, has gotten us through many security audits with minimal findings. Django's ORM, probably the best part of Django. In addition to letting you build queries quickly, also has all of those advanced features for query tuning and performance optimizations, which I will come back to later. Django's migrations, the best part of the ORM, are really good for managing schema changes on a mature product, which we do. If you think your schema won't change, you're wrong, it will. Or it means you're not building any new features, in which case, okay. Django forms are really useful for us as well. As I mentioned, we actually use Django for a lot of our front end. And Django forms make rendering forms and validating forms just easy on new features. And finally, native text translation. We haven't used this on a ton of projects, but on Champ we translate the applicant side into 6 different languages, and Django makes that really easy. Django does not work alone, though. 4 libraries that we use very heavily on Champ that I think are fairly broadly applicable. Django storages for file storage lets you use block storage like S3 as just a magical extension of your database. Django SES lets you use Django's email interface with Amazon SES, makes email sending very easy. PDF Kit lets you use Django templates and convert them to PDFs, so for example, for our letters and notices generation. And that also works very well with a lot of Django templates' other features, like translations. So we can generate these in English and our 6 other languages just by using Django's translation framework in our templates that we pass over to PDF Kit. Finally, Django Crispy Forms. This is really good for that final step of styling our forms. Django Forms is good for at least getting the fields on the page, doing the validation, but for making them look nice, doing the layout, Django Crispy Forms is a great tool for that. I could go into way more detail on Django tools, and I did. So if you want to know more about that, here's my DjangoCon talk from 3 years ago, rapid prototyping, and I go into more detail on a lot of these tools. 2 things I don't cover in that are Django and front end. So I've got 2 things I want to cover here. One is, this might be a blast from the past for some of you, data tables. Data tables is a JavaScript library that takes an HTML table and it does front-end sorting, paging, and filtering. So it takes your boring HTML table and turns it into that dynamic stuff that the users crave. It works really well with Django. In a Django template, you just get your regular for loop. You can throw whatever if conditions you want in on to make this the columns in this table. And then a single line of JavaScript goes and turns this into this front-end dynamic table. And that's for the basic stuff, but the thing that's great about data tables is that it also gives you the advanced stuff too. You can customize your filters, you can customize your sorts, you can even throw in back-end paging when you start hitting like more than a few hundred things in that table and need it. So really great for just getting those front-end tables. We use these a lot on the staff side. You need a table of applicants, you need a table of letters, you need a table of uploaded documents, things like that. The big one that really ought to be its own talk, maybe next year, Django and Vue. So as I mentioned, we're not using what might be the traditional Django and Vue split, where Django's the back end, Vue's the front end. We're using Django Forms, we're using Django templating. Django is powering most of our front end, but what Django can't do is that front end dynamism, where you check a box and another form field shows up, you uncheck it, it goes away. If Django could do that, I'd use front-end frameworks half as much. I'd love if it could. So what we do instead is we use Vue to power that front-end dynamism, and the great thing about Vue is all it needs to run is, Vue calls them directives, but they're actually HTML tags. So all you need to do in your Django template is throw in some extra HTML tags, stick a Vue app on the bottom of the page to take over that rendering once that all makes it to the client, and you can have Django render most of your page, leaving some instructions to Vue for what it should do, and then Vue can pick it up from there. Now the challenge is, how do you get the data over to Vue? Vue needs more than just, okay, here's the page itself, it needs some data. We got two tricks for that. One is we made a custom Vue directive to pick up Django initial form data. So we're using Vue with Django Forms quite a bit. It's great to pass initial form data into Django Forms. So we have a custom Vue directive using Vue's before mount to go pick up that initial form data off of those HTML elements. For more complex cases, Django has a great trick for this, which is the JSON script tag. So for cases where we have custom Vue directives that need a whole structured payload of data, JSON script, this is a Django template tag built in, is great for just getting that data over to where the front end can pick it up. So that's a little abstract. Here's what it looks like in practice. Here is a Django, a couple of the fields of a Django form, gotta fit on a slide, rendered with additional Vue tags. This Vue input, this is a custom Django template tag that we made to add in those extra HTML tags that Vue needs to render this form field, like vModel and vIf. And so what we can do here is, here's a checkbox. If you check it, this field shows up because it's got that vIf tag and conditional on the value of this checkbox. If you uncheck it, it goes away. Magic. Now, the one piece that really is magic is how did we get our Vue files to a place where Django could actually notice and load them. So this guy right here, we've got Vite compiling our Vue, our code, and we have a few extra lines in our Vite compilation in order to make these per page JavaScript files. And then all we have to do is put them in a subfolder of static files, and then we can just use Django's built-in static tag to load them. So Django and Vue actually work pretty well together if you're willing to break the mold a little bit on Vue wanting to run your whole front end. All right, challenges. There have been plenty. I'm going to give you my top 5, both in terms of interesting and broadly applicable. So first, data migration. We didn't have our traditional easy data, not that data migration is never easy, but we didn't have the straightforward migration of source database, target database, build a mapping, run it. We had over 200 housing authorities we were trying to migrate data from. And better yet, not all of them had a database. Some of them were working exclusively on paper. So we first took two categories, but the people with digital systems, the people who were going to be doing manual data entry on paper. Digital systems, we built, for each one of these categories, we built a common format that we're trying to get their data into that we could validate and import. So for the digital systems, we went for CSV. The reason for this was most of these systems had reporting engines. They could configure, create a custom CSV export. So this was just a great way to get data out of these systems in a fairly standard format. And then for paper, the reason we went with Excel was so we could actually bake these validation rules into the Excel files, so the people doing data entry, could basically have that validation in real time as they were typing. We then took those files, we did validation on upload, and we spit out the whole list of errors. Very tempting to spit out the first error and stop, but that's very frustrating. People that have to upload the file, get an error, fix it, upload again, fix it. So we give a whole list of errors that can fix them all in one go. And we try to be very forgiving in our data parsing. So ignoring out of order columns, ignoring extra columns at the end. Massachusetts has those leading zeros in the zip code. We'd assume a 4-digit zip code had just a 0 at the front, things like that. And then at the end, we had to do a massive duplicate reconciliation because applicants had applied to multiple housing authorities. We were migrating data from each housing authority, and we wanted to get to one application per household. So duplicate reconciliation, another big problem. This was a problem not just for data migration, but also on an ongoing basis. We had 3 layers of defense for this. The first layer is preventative measures. This does not help with data migration. There were duplicates in the data migration. But for the ongoing basis, preventative measures, that's the first line of defense. So here, for both applicants and staff users, when somebody creates an application, we have a step where they have to check, is this person already in the system? And if they are, we stop them. It's not foolproof. For example, some people change names, things like that. But it does catch a lot of the duplicates that would be making it in. So then after that, the next layer is automatic merge. We have a strict set of criteria for auto merging. And if two or a cluster of applications meet on these criteria, we merge them automatically every night. The third layer of defense is the hardest, at least in terms of staffing. Here we flag likely duplicates. These are things that meet on several of a whole bunch of criteria, and put them into a queue for review. And then also staff users, as they're encountering applications in their work, if they find a cluster of applications they think are the same, they can also put that in the queue. And then somebody from the Office of Housing reviews these on a regular basis and determines duplicate or not. Once we've got a group that we know is a duplicate, then we merge them. So we pick which one's canon. We have a whole set of rules for this. The ones that aren't canon gets marked as duplicate, taken out of circulation, linked to that canon application. And then we copy over only the non-sensitive data. And this might seem a little weird or a little unusual. I actually recommend it because if you have an erroneous merge, you don't want an information leak. So we're copying what waitlist the person's on, what timestamps, but we're not copying sensitive data like financial information. Performance has been another big challenge on an ongoing basis. I mean, just between user volume and data volume, those are both things that can exacerbate performance. So the first thing you need is to know where your performance problems are. Don't just start optimizing, you gotta find where the problems are. We use Scout APM. Pretty much, application performance monitoring is the thing to look for. All of these are gonna be paid products, or almost all of them. We've had a lot of success with Scout. It shows you both your slow pages and time stack traces. It also shows you memory use, pages that are high in memory use. I could give a whole talk on performance, so instead here's one slide on it. Here are my top 5. These are not going to cover everything. These will cover maybe a majority of the performance problems. The most common performance problems, too many database calls. So if you're making too many queries, it's probably because you stuck a foreign key reference in a for loop. That's called n+1 queries. Select related or prefetch related, these are built-in Django tools to pull those foreign key references out and do it as a single query at the top of the for loop. You can also do it manually, like just query that related table yourself and unpack it. But that's one way to avoid making too many queries. Also, if you're making database updates or creates in that for loop, you're going to end up with a whole bunch of database calls. Pull that out at the end with a bulk create or a bulk update. Slow queries, another common problem. There's a whole endless list of things you can try, but at least a couple things to have at the top of your list. Indexes, and then also Django's annotate and F queries can really help you untangle slow queries. A weird one we ran into is repetitive template rendering. It turns out that if you try and render over 100 Django forms on a page, you start to break that 1 second load time barrier that we're trying to stay under. So for example, if you have a list in one of these tables, and you have a button on the table to open a modal that has a form in it, and you just render one modal per row in that table, it takes a lot of time. If you offload that to a separate page, so that button just takes you to another page, or you use your front-end framework like Vue to render that modal in a dynamic fashion, that's a great way to take that off of the server-side rendering. Last thing, this is mostly for like background tasks or things that are iterating through a whole table of results. If all you need to do is read them, instantiating like 1 million Django models takes a lot of time, and if all you need to do is read the data, query set.values can give you like a 2x speed up on these, like run through a whole bunch of Django objects. Speaking of reports, another big challenge for us has been reporting and our data pipeline. Reporting is a little more forgiving in terms of runtime. These usually run as background tasks. So there the concern is both correctness and also memory. So for memory, you want to do a paged iteration to keep your memory footprint from growing as your data grows. So what that means is you take a slice of say 2,000 objects from your table, then the next 2,000, the next 2,000. But if you're going to do this, you have to be careful. The temptation, and Django actually makes this very easy with its slice syntax, is to do limit offset paging of a table. Don't do this. By the way, the Django built-in paginator secretly does limit offset paging. Don't use that for iterating through a database table. That's for front-end paging of your data. What you want to do is successive primary key filtering, where you grab first 2,000 primary keys, then the next 2,000 primary keys, because offset's a linear time operation. And so a limit offset walk through a table, that's a quadratic time iteration. And you won't notice that at first, but when you hit 1 million records, you absolutely will. One other thing on the correctness front, and also just kind of architecture front that we've had to do, is create an intermediate data schema between our system and the data warehouse that we're exporting data to. Two really big reasons to have an intermediate data schema. One is schema independence. We change our schema all the time. I mentioned Django migrations, great tool. That only helps if you can actually change your data schema without breaking downstream systems. So we want to be able to change our data schema without breaking reports running against the data warehouse. As long as we can maintain compatibility with that intermediate schema, we're good. And if we can't, if we're making a change big enough, then we can release a new version of that intermediate schema and coordinate that rollout with the data warehouse team. The other reason is computed values. Something you really want to avoid is having duplication of logic to compute values, because then that logic gets out of sync, then there's data discrepancies, it's a whole mess. So with that intermediate schema, we can also include computed values in our export to the data warehouse and not have to duplicate that logic. The last thing I want to cover, really interesting challenge that we ran into, was many layers of what we needed to do to get zero downtime deployments. We've got users in the system all the time. We want to be able to deploy without users noticing any downtime, at least for a typical deploy. We do downtime deployments occasionally, but at least our typical one we want to be able to do without any disruption. So we got actually 4 things we needed to do to handle this. First, infrastructure-wise, we need to make sure we always have a server running. So in Elastic Beanstalk, you can do this with immutable deployments. Plenty of other hosting platforms have an equivalent. And what this means is we've got a load balancer, we've got servers behind it, we've got our old servers running, we're going to add new servers with the new version of the application code in rotation with the load balancer, and only once those are up and running, we take the old servers away. So that means there's always a server there to handle incoming requests. But we also need users to actually get a consistent application experience during the deploy. If people are hitting old servers, new servers, it's going to be a whole mess, and depends on what the feature is that might not make any sense. So sticky sessions on the load balancer means that users, once they're hitting a server, they're going to keep hitting that server until we take it away. And this means they're getting a consistent both back-end experience and also experience of the template Django is rendering. But that's not enough, because we also have JavaScript in the mix. So we're also serving JavaScript files off of the servers. We're just using Nginx's static file serving to serve those JavaScript files from the servers. And so with the sticky sessions on the load balancer, that means whichever server somebody's going to, they're getting a consistent version of the JavaScript bundle and the back-end code and the front-end code. And that's great except for the database. The problem with the database is we got to run migrations. We now have a new database schema. People are talking to an old version of the server, and that doesn't work with the new version of the database schema. We're still going to have a problem. So the primary solution for this is backwards compatible migrations. That is a whole other topic, and if you want to know more, check out my DjangoCon talk 2 years ago on Django migrations. I go into backwards compatible migrations and how to think about them in detail there. All right, that is all I have for you today. Here's those links if I went past one too fast. Also, here's my email. Happy to give you a copy of the slides. I'll be sticking around afterwards for questions. But email me if you anything that you don't have time, I don't have time to talk about, or if you need software consulting work. Thank you.